Hey guys, today we're going to talk about lesson 1-6, equivalent ratios. Today's date's 11/13/19. So we've talked about these guys before, so let's just define them one more time. Equivalent means equal value, equivalent ratios. So there are two ratios that have the same value, just like two fractions are equivalent if they have the same value. It may not look the same, but once you reduce them, they'll have the same. So this applies not only to ratios, but it also applies to rates. So ratios or rates, once simplified, so when you reduce it to lowest terms, that have the same, oh my goodness, that have the same or equal values. Do you hear my cat? She's crazy. Sorry. Sometimes I have to scare her. Okay? So, how do we figure out if two ratios are equivalent? So I'm going to give you a couple options. To determine if ratios or rates are equivalent. Okay, so we had a question kind of like this on the quiz that we talked about before, so this isn't really brand new. We're just kind of highlighting this idea where we needed to compare two rates and see if they were equivalent. So one idea is to use unit rates, because you can always divide top and bottom by the denominator, right? Doesn't matter if it's a repeating decimal or leftovers or whatnot, you still will be able to compare the numerators if the denominators are 1. So, step 1, we're going to write the ratio, or write, depending on how they give it to you. If it's written horizontally, we're going to write it vertically. So write as a ratio, i.e. fraction. Then convert to a unit rate. Okay, and so how do we do that? We divide numerator and denominator by the denominator. To get the denominator equal to 1. Okay? So it's simple as that. Now, this strategy is good in this circumstances, so best to use if the numbers oh, that was sloppy. Let's try that again. Numbers divide easily and without remainders. Now, that's not to say that you couldn't always use this strategy, but this is when it's best, is if you can divide the numbers super easily to get the denominators to equal 1, okay? So what's a second strategy? Well, that's going to be using equivalent fractions. So use equivalent fractions. So what on earth am I talking about? Well, we're going to rewrite each situation it isn't already written as a ratio or a rate. As a ratio or rate. Or, which is the fancy way of saying, write it like a fraction. Okay. Then we're going to temporarily set them equal to each other. It's just mainly a way of kind of putting the problem together. Okay. And then see if you can, going back to earlier part lessons, scale up. Remember, that's a multiplication step, or scale back. Remember, that's a division step. So that you can get numerator 1 to become numerator 2. Or denominator 1 to become denominator 2. Okay? Let's do different colors, do orange. So if you scale up or back by the same number, then you would have equivalent ratios or rates. I always do that. Drives me crazy. Rations. Why do I always say that? Okay. And if the scale up or scale back by different numbers, they're not going to be equivalent. Okay, so when is this a good strategy to use? And again, we're going to go through examples. It's always good to write down the words first and then go practice. Best to use when a unit rate is not easy to calculate. Okay, so enough of this jabbering. Let's get on to the practicing. So on the next page, already glued down my examples, and I've left a whole big blank space on the right if I need extra room to work, which most likely I will, especially on number 4. So number 1 says 36 t-shirts in 3 boxes, 60 t-shirts in 6 boxes. The directions ask us, determine if each pair of rates is equivalent, and then explain your reasoning. All right, so let's see what we're going to do. Let's go to unit rates. Why? Because I know that 3 goes into 36 evenly, and I know that 6 goes into 60 evenly just by looking. So that's what we're going to try over here. So we're going to do 36 t-shirts, 3 boxes, and we're going to divide top and bottom by the denominator. So I'm going to divide top and bottom by 3, and that's going to equal 36 divided by 3 is 12 t-shirts, and 3 divided by 3 is 1 box. Okay, so that's the first guy. Let's check the second guy. We're going to take 60 t-shirts and 6 boxes, when we're going to scale down to 1, so divide top and bottom by the denominator 6, we end up getting 10 t-shirts over 1 box. Okay, so now I look, and I've got 12 t-shirts versus 10 t-shirts. Well, I can draw a conclusion right there that they are not the same. So I said the rates are not equivalent, and the rates, because they have different labels, are not equivalent. Because $12 t-shirts per box is not the same as 10 t-shirts per box. Okay, that's pretty basic. All right, let's look at the next one. I've got 42 flowers in 7 vases and 54 flowers in 9 vases. Well, I know 7 goes into 42 evenly, and I know that 9 goes into 54 evenly, so I'm going to try unit rates again. So we've got 42 flowers in 7 vases. So we're going to simplify. So you divide both by the denominator 7, and that's going to give me 42 divided by 7 is 6. So I get 6 flowers per 1 vase. Okay, let's try the other guy. We've got 54 flowers. So notice I am writing these as rates like fractions. Okay, and 9 vases. Same idea. We're going to get a unit rate, so we're going to divide top and bottom by 9. And that's going to give me 6 flowers per 1 vase. So I look at my results, and I have 6 flowers per vase and 6 flowers per vase. So guess what? These rates are equivalent. Why? Because their unit rates are the same. The rates are equivalent because they both have a unit rate of 6 flowers per vase. Okay? So in both of these cases, we had unit rates that work. So both of these used unit rates. Yep, sorry, let's try that again. And I chose that because I knew the denominators went evenly into the numerators. Okay, so let's look at the next one. Marsha made 10 bracelets for 5 friends. Jen made 12 bracelets for 4 friends. Are these rates equivalent? Explain your reasoning. Here we go. Let's keep doing it. I notice that 5 can go evenly into 10. 4 can go evenly into 12. This is going to be a piece of cake. So let's talk about Marsha. Marsha, Marsha, Marsha. Only your parents will laugh at that one. Bracelets over 5 friends. So again, I'm going to create a unit rate by dividing top and bottom by the denominator of 5. And that's going to give me 2 bracelets and 1 friend. So each friend's going to get 2 bracelets. Okay, that's cool. Let's check out the next person. This is going to be Jen. And she's got 12 bracelets per 4 friends. And again, I can do a unit rate. Divide top and bottom by 4. and I get 3 bracelets per 1 friend. Well, that doesn't seem very fair. So my conclusion is this isn't the same. So these rates are not equivalent. Because Marsha makes 2 bracelets for each friend, while Jen makes 3 bracelets for each friend. Okay. I think I like Jen better. All right, last one says, Mrs. Jeffries has 12 girls out of 16 students on the student council. The Earth Day Committee has 4 girls out of 8 students. Are the ratios equivalent? And explain your reasoning. Okay, first thing I noticed, 16 doesn't go evenly into 12. So this one is not going to work at all. So I'm going to go ahead and work this problem off to the side. So let's do... We have Mrs. Jeffries has 12 girls out of 16 students. And we've got the Earth Day Committee has 4 girls per 8 students. Okay, so what we're going to do is try that second strategy, and we're going to take those 2 ratios and we're going to put them and temporarily set them equal to each other. So this is the one that I said, wait till you see this one. Okay, now what we're going to do is look individually at the denominator and see if we can get the first denominator to become the second denominator, and then we're going to test the numerators. Okay, so here we go. Are you ready for this? Let's see. To get from 16 to 8, I can divide by 2. To get from 12 to 4, I can divide by 3. Guess what? Dividing by 3 is not equal to dividing by 2. So our conclusion is, let's see if I can write it here. The rates are not equivalent. Because you can't simplify the fraction by the same value. To equal the second fraction. And there you have it. So those are the 2 strategies demonstrated to you. Have a good time with this. We'll see you guys tomorrow and we'll talk about this. All right, bye.